Hey y'all. In this video, I'm going to address an issue that I get a lot of questions on, and that is for the beginning CNCer, what would be a good selection of bits to have to see me through the majority of the projects I'm going to try to take on. So we're going to talk about bits in this video, what I consider to be a good selection of bits to have. Again, this is just my opinions. Now, let me qualify this by saying that I'm talking in this video about bits for wood. I mean softwoods, hardwoods, sheet goods like plywood, MDF, HDF, MDO board, things like that. I'm not talking about metals at all. And I'm not talking about engraving or cutting plastics or acrylic, foam, be it urethane or polystyrene. I'm talking strictly about wood and wood products in this video. So, to get started, as a general rule, 2 flute bits are what you want to look at. You want to avoid 3 flute and 4 flute bits if it's at all possible. Those are made for metals and other materials. 2 flute bits, in some case single flute bits, are the best choice for wood. All of the bits I'm going to show you in this video are 2 flute bits. So that's what I'm going to concentrate on. Now, there are going to be buku links in the description box below. Some of them to the bits I'm going to show you, others to alternatives to those bits, so that you can get an idea as to what's out there and in what kind of price range to look for. Now, on that subject, I am not going to recommend the more expensive, pricier bits. I know some of the more experienced CNCers are very brand loyal, and names pop up all the time. I'm going to stay away from those pricier bits as a starter kit, simply because the beginning CNCer is going to be learning the machine and doing a lot of experimenting. And to me, just my opinion, it doesn't make a lot of sense to ruin a $40 bit on the first couple of attempts to run a piece of G-code. So I'm not going to recommend the super cheap bits, and I'm not going to recommend the more pricey bits. I'm talking about good quality bits that are in the center price range that will see you through most of the projects the beginning CNCer will want to take on. Now, I've only been in CNC for a little bit less than 5 years now, but I've been a woodworker for getting close to 50. And one thing I was taught at a very early age is start with the basics and then purchase tools as you need them. So what I'm going to do is recommend 4 categories of bit that the CNCer should have on hand to get through most every project you'd want to take on as a beginner. Then let you build up from there. You can purchase different angles of V-bits. You can purchase smaller or larger ball noses from there. But the bits I'm going to recommend should see you through just about everything you'd want to attempt to cut. So that's enough of the talking head. Let's go ahead and zoom in and take a look at a few bits, and we'll look at my recommendations. Now, before we get into talking about the bits themselves, let's take a couple of seconds to talk about the Kaulitz. Now, I have here the 3 Kaulitz that I use on my Porter Cable 890 series router that I have mounted in my CNC. The Porter Cable router came with this collet made for bits with a 1/2 inch shank diameter, this collet made for bits with a 1/4 inch shank diameter, and then I purchased from Elaire Corporation, and I'll put a link in the description box below. I purchased this collet, which is made for bits with a 1/8 inch shank diameter. Hilaire sells Kaulitz of various sizes for most of the popular routers out there. Porter Cable, DeWalt, Bosch, and several others, Milwaukee, etc. I'll leave a link in the description to Hilaire Corporation where you can check through and maybe find a collet that'll fit your router, that'll hold different sized bits. But the reason I'm bringing up the Kaulitz is because the first thing you need to do is you need to make sure what size collet your router or spindle takes. If you have just a 1/4 inch collet, which is the most popular size, then you're going to be limited to using bits with a 1/4 inch shank diameter. Now, you can get reducer bushings that will allow you to run a 1/8 inch shank diameter in your 1/4 inch collet. I've never been a fan of those. It's just my personal opinion. A lot of people use them. They like them a lot. It's just my personal opinion. Your mileage may vary. The important takeaway from this is make sure you know which size collet you have for your router or spindle. Okay, the first category of bit we're going to discuss is the straight cutter or spiral cutter, also known as an end mill. I have here a carbide tipped straight bit. They're also known as mortising bits. These are standard router bits that are available at your local big box store, or you can order them online. Here we have an upcut spiral straight mortising bit and a downcut spiral straight mortising bit. Now, as I alluded to in my video on climb cutting versus conventional cutting, the way you can tell the difference between the upcut and the downcut is if you look at the spiral. The cutting edge on the upcut bit is on the top edge of the spiral. Conversely, on the downcut bit, the cutting edge is on the bottom edge of the spiral. Now, if you'll notice, the spiral also wraps around the center of the bit in a different direction. On the upcut, it wraps around clockwise. On the downcut, it wraps around counterclockwise. That can be a little confusing at first, so I say the way to more easily identify what kind of bit you're looking at visually is remember that on the upcut, the cutting surface is on the top edge of the spiral, and on the downcut, the cutting edge is on the bottom surface of the spiral. There are a few things to pay attention to when you're deciding on which bit to buy. First and foremost is the shaft diameter. You need to make sure that it will fit in the collet you have for your router. Second is overall length. How long is the bit? Will it be able to reach down into the material as far as you want it to go? Third is the cutting length. Now, on all three of these bits, the cutting length is 1 inch. Since the overwhelming majority of the material I cut is 4/4 stock, meaning the finished thickness is somewhere around 3/4 of an inch, this 1 inch cutting length gives me plenty of cutting depth to cut all the way through the material. If I were cutting into 6/4 stock, i.e. a 2x6 or a 2x8, none of these bits would be able to cut all the way through because the cutting edge is not long enough to reach all the way through the material. So that's something to pay attention to, is the cutting length of the bit. The next thing to pay attention to is the cutting diameter. Just because a bit has a 1/4 inch diameter shank doesn't mean that the cutter cuts a 1/4 inch diameter. You can get bits that have a 1/8 inch cutting diameter with a 1/4 inch shank. You can get bits with a 3/4 inch diameter, cutting diameter, with a 1/4 inch shank. So pay attention to the cutting diameter, the cutting length, the overall length, and the shaft diameter. Another thing to pay attention to is the style of the tip. Now, both this upcut bit and this downcut bit are straight mortising bits, and they are designed to be plunged straight into the material. This straight bit here, however, is not designed to be plunged straight into the material. If you look at the tip of the bit, the cutting surface of these carbide tips do not go all the way across the bit. There's a slight gap in the center. That means if this bit were to plunge into the material straight down, there's the center of that hole it's making is not going to be cut. That can lead to burning. Depending upon the diameter of the bit, the material, and how fast you're going, it can also break a cutting edge or break the bit itself. The way to use this, if you're going to use it to cut a profile, would be to ramp in the plunge move so it doesn't attempt to plunge straight down. Instead, it would move in this direction as it plunges so that the leading edge of the bit cuts away the material so there's nothing there when that center gap gets down into the cut. Do not attempt to drill holes straight down with a straight bit that does not have a cutter all the way across the bottom or a downcut bit. Just to be clear on this, what I'm talking about is drilling a hole straight down. I'm not talking about a plunge and a wiggle like such. I'm talking about plunging straight down. Do not use a downcut bit. Do not use a straight bit that doesn't have a cutter that goes all the way across. Use an upcut bit, always. The reason is, with a downcut bit, forcing those chips and the dust down into the hole when you're plunging straight down like that, the chips have nowhere to go. They're going to sit there and grind against one another as this bit spins. That's going to create friction. That's going to start a fire. And I say it will start a fire. I know this personally. I did it. I don't know a fella who knows a guy. I did it myself. The bit plunged in. Those chips had nowhere to go. And when the bit pulled up out of the 3/4 inch plywood I was cutting, glowing, burning embers fell off of that bit. I had to hit emergency stop, move everything out of the way, took my material off, and I had a big black charred spot on my spoil board that was burning. Dumped a bunch of water on everything, put the fire out, and everything was good. But it ruined my spoil board, ruined my project. I had to start over. Simple rule to remember. Upcut bit when drilling straight down. And it doesn't matter if you're peck drilling or drilling all the way through. I was peck drilling. It doesn't matter. Use an upcut bit to drill straight into the material, always. Now the next category of bit I'm going to get into is a surfacing bit. This is not necessarily a surfacing bit. This technically is a straight mortising bit, just like the others that I showed earlier. But I use it as a surfacing bit. It's a 1/4 inch shank, 1 1/4 inch diameter, straight mortising bit. And you can see the carbide tips on this bit. Again, do not go all the way across the bottom. There is a section here where there is no cutter. This bit is used to surface my spoil board or surface rough stock. The thing to remember about a bit like this is when there's no cutter all the way across the center, the plunge moves have to be ramped in. so it doesn't attempt to plunge straight down into the material and bottom out against this section here where there's no cutter. Again, you would want to ramp the plunge moves in at least double the diameter of this bit. In my case, this being 1.25 inches, it would be 2.5 inches would be the distance I ramped in my plunge moves. Now, you can get what's known as a bottom cleaning mortising bit. And these have a cutting edge that go all the way across the bottom. It is split in half. One will be facing one direction, one will be facing the other direction, but it does have a cutter all the way across the bottom. Those you do not have to ramp in the plunge moves. I still do just to make it easier on the bit, but it's not as mandatory as it is on a bit like this, where the cutter edge does not go all the way across the bottom. The things to look for on a bit like this is the shank diameter, the cutting depth, the cutting diameter. The next category of bit we're going to discuss are V-bits. Now this is where you can get into trouble and spend a lot of money that you don't need to spend. And I'm a good illustration of that. Here we have a 90-degree V-bit, carbide tipped. Here we have a carbide tipped 60-degree V-bit. And here I have a solid carbide 30-degree V-bit. When I first got my CNC, I wanted to try to cover every contingency that I could possibly ever run into when it came to V-carving. Then I got to actually working with the CNC, and I discovered I did not need this 30-degree V-bit. You can look at it and see I've never had it chucked in the router. I think I may have put it in there once just to see what it looked like, but I've never cut anything with this. I just don't need it. And again, I learned a long time ago to buy the basics and then accessorize and expand as you need the tool. I just didn't take my own advice. For about 85 to 90% of the cutting I do with a V-bit, I do with the 90-degree V-bit. That's my go-to. The remaining 10 to 15% of the V-carving I do is done with the 60-degree V-bit. I just don't do anything that small. Your mileage may vary. The things to look for when you're buying a V-bit are, again, the shank diameter, the cutting diameter, which is the measurement from the edge, this edge here of the cutter, to this edge here of the cutter, the angle of the cutter, this is from this edge of the cutter down to the point and then back up to that edge of the cutter. On this bit, that measurement is 90 degrees. On this one, it's 60 degrees. Some software, when you input a bit into your tool database, they want just one single angle from the tip to the edge of the cutter. In the Vectric software that I use, they want the total angle. So from this edge to the tip, back to this edge. In this case, it would be 90 degrees. Check with your software and see what measurement they want. On this bit, if they only want half of the cutter, it would obviously be 45 degrees. This one would be 30. On the Vectric software, they want the total angle. The other thing to pay attention to is the depth of cut. Because again, if the bit can't cut deep enough into the material, it's probably not the appropriate bit for the design you're attempting to cut. Again, shaft diameter, cutting diameter, cutting depth, and the angle. The final category of bit we're going to talk about is the ball nose end mill. Here is another area where you can really get yourself into trouble and spend a lot of money that you don't need to spend. Here I have a 1/4 inch ball nose end mill, an 1/8 inch ball nose end mill, a 1/16 inch ball nose end mill, and a 3/64 inch ball nose end mill. I have never used the 3/64 ball nose, so I could have saved my money on that one. They are not hugely expensive, but there's no sense spending money until you need the tool. The things to pay attention to when we're talking about a ball nose end mill are, again, the shaft diameter, the cutting length, the cutting diameter, and the tip radius. The tip radius being from the center of the bit, the radius of the bottom cutting edge. These are used in 3D carving. You would run the 3D roughing toolpath with the larger ball nose, then go in and do your finishing toolpath with the smaller ball nose. Now, without getting into the 3D carving discussion, let's think about this because everybody wants to get as much detail as they can. And that's great. However, let's think about machine times. Normal step over on a 1/4 inch ball, well, on any of these ball nose bits, is about 20%, meaning when the ball nose gets finished carving, it will step over 25% of its cutting diameter, then make the next pass. When you start your finishing tool path, normal step over on a finishing tool path is 10% or less. I've seen people use anywhere from 8 to 10%. I generally run 8 or 9% myself, just depending upon the project. So if you have a ball nose cutter with a 1/16 of an inch tip like this one here, figure 8 to 10% of a 1/16 of an inch. That step over is minute. It's very, very small. This is why we end up with 5, 6, 12, 18, 24-hour machining times. If you're trying to cut a 12-inch by 12-inch project with a 1/16 of an inch radius ball nose with your step over of 8%, don't just bring a lunch, bring dinner and breakfast. You are going to have a long, long machining time. So you've got to find the balance between efficient cutting and the level of detail you really need. Again, the things to pay attention to when looking for a ball nose are the shank diameter, the cutting diameter, the cutting length, and the tip radius. So summing up, these are the bits that I would suggest for the CNC beginner who wants to do most general work. And that would be either the straight mortising bit, the upcut and downcut spirals. The choice is yours. If I were to break it down even further, I would suggest just an upcut spiral and a downcut spiral. I would also suggest a surfacing bit And in fact, that would probably be the first bit you chuck in your router to surface your spoil board to make sure it's nice and flat after you finished building or assembling your CNC. I would then suggest the 90-degree and a 60-degree V-bits. Those should get you through most of the V-carving you'll ever want to do. I would then also suggest a 1/4-inch ball nose and an 1/8-inch ball nose. Those should get you through most of the 3D carving that you'll want to do when you're just starting out. Just keep in mind the things that we talked about as far as shank diameter, cutting length, cutting diameter. In the case of the V-bits, the angle of the bit, and in the case of the ball nose, the tip radius. So those are my suggestions for a beginner CNC starter kit, if you will. Now again, there are a bunch of links in the description box below to all of the bits that I showed you here, as well as some alternatives to those bits so that you can gauge for yourself some of the prices and availability of the bits that are out there on the market. And again, I've gone for bits that are of good quality but don't have an extravagant price. And I've avoided the El Cheapo bits while I was in the process. Now, you may have ideas for other bits that you might need, and that's great. But again, these bits should see you through just about any project you'd want to take on as a beginner. So, disagree? Let me know in the comments below. If you have any questions or any comments, as always, feel free to leave it down in the comment section. If you'd rather not leave a public comment, head over here to my website, marklindsaycnc.com, then click this Contact Us link. I read every message I get through marklindsaycnc.com, and I do my best to respond to each and every one of them. marklindsaycnc.com is sponsored by Harneal Media, the web design and web hosting company that specializes in websites for the makers and the maker community. Harneal Media and I are both proud members of the Makers Media Network. Well, I hope you got something out of this video. If you did, click that thumbs up button down below. And if you'd like to follow along with my Beginning CNC series or any of my other CNC adventures, I do hope you click that subscribe button and then click that little bell button right next to it. That way you'll get a notification the next time I post a video. Now, if you know somebody who might benefit from watching this video, I hope you'll share it on Facebook or Instagram or Twitter. Heck, share it on all three. I do appreciate that as well. But as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch this video, and y'all take care.